This episode is brought to you by Indeed. When your computer breaks, you don't wait for it to magically start working again. You fix the problem. So why wait to hire the people your company desperately needs? Use Indeed's sponsored jobs to hire top talent fast. And even better, you only pay for results. There's no need to wait. Speed up your hiring with a $75 sponsored job credit at Indeed.com/podcast. Terms and conditions apply.
This Friday,
I'm an angel. See the wings?
don't miss the new comedy Good Fortune, starring Seth Rogen, Aziz Ansari, and Keanu Reeves. Critics rave. It's Heaven Sent.
Let me have a budget, guardian angel?
Kinda. You were very unhelpful.
Good Fortune, directed by Aziz Ansari. Rated R.
We're broadcasting relationship truths and scientific discoveries with a comedian's touch. The Last Show with David Cooper.
It's time for science. We have a visitor from outside the solar system coming close to the Earth. And by close, I mean, close to the sun, not really that close. At the end of the month, it is 3I Atlas. It is the third object that is interstellar that we know of that is visited us, which is the past tense of visited. Probably. We are joined by scientist Dr. Jesse Rogerson, who's a professor at York University. He's got a book called Daydreaming in the Solar System, which you should buy. I definitely have bought it and read it, probably. Jesse, welcome to the show.
Hey, David. Thanks for having me back.
So, I know we talked a little bit about this comet, but as it gets closer, I feel like it's getting more and more exciting. And the more we learn about it, the more we realize it's different than any object we've seen before. So that means it's an alien visitor. Probably not.
Clearly, all signs point to it being an alien visitor. There is no other conclusion that could be drawn from all of the data that has been, and they've gathered a lot of data on this comet. I just, of course, the most obvious solution to this is that it's a comet. It's just a comet that's acting weirdly. And we could talk about the weirdness of it. So it came from out of the solar system.
We should, but okay. We've only observed 3 objects that have come from outside our solar system. So we have nothing to compare it to. We have no sample set, no sample. So yes, this object from interstellar space is weird. It's a little unusual. Its tail's pointing in the wrong direction, although we have examples of comets with tails pointing in the wrong direction. The composition is odd, but maybe all objects out there are weird, and that's normal.
Yeah, the thing about this is that exactly the sample size is small, and the object itself seems to be coming from a region of our galaxy that is older. So it's an older population. So the scientists are starting to think that based on the observations, based on the color of it, based on the chemical composition of it, based on the trajectory that it came into the solar system, how fast that it's moving through our solar system, all of this stuff suggests that where it came from is an older region of the Milky Way galaxy. And if it's an older region, then that would mean that the material from which it was created is different, has different mixing of chemicals than the material that formed the stuff that our solar system is made of, or even stuff that's nearby, other solar systems that are nearby. So if you have an older population, then when you see things like the color different, or the outgassing is different, or it's the coma, the outgassing that's creates the coma is more water than you expect. That could just be because it's an object of different population that we've never observed before.
Interesting. So what is it made out of? What is this comet made out of that is unusual, that isn't like comets that are gravitationally bound to our solar system?
So it has a lot of the same stuff. It's just the ratios that are weird. For example, it has much more carbon dioxide to water than comets you'd find here in our solar system. So that ratio is really, really high. It also, and it's not just about the chemicals that are there. I mean, it also has a weird nickel ratio, a nickel iron ratio. So you have these small differences indicating a gas cloud that it formed from was chemically different. But what I find really interesting is the way that it's outgassing. So it's this. We don't even have an exact size of how big it is because we're not sure what's going on inside that coma. It could be a kilometer in size. It could be 5 kilometers in size. It could be less than a kilometer. But somewhere down there where that nucleus of the comet is, it's coming through our solar system, heating up and outgassing much different than a normal comet would. In fact, it's outgassing water much farther away from the sun than it normally would, and any comet here would. And I think that either means two things. It means that the amount of water on board is different, or how it's captured is different, but it might be just suppressed under the rocks differently, suggesting that as it's probably been floating through our universe in the deep depths of space in between stars for billions of years, and it has undergone hardening and coverage of interstellar dust that has suppressed the ices. And so when it gets warmed up and the ices turn into gases, they come out in weird amounts that we're not used to seeing in our solar system, which I think is really interesting if you're trying to figure out what's going on in other solar systems.
I just learned the plural of ices, which is to me just a fascinating thing right there. There are scientists making claims that it's an alien visitor. I don't think we can rule out that possibility, but there is no good reason to believe it is true.
It's like the same with UFOs, right? Like UFOs, when people say they see lights in the sky moving around, a possible explanation is that it is an alien spaceship flying around your backyard. That is technically possible, but it's definitely not the most likely scenario. And, the famous Avi Loeb is been very outspoken about all the the 3 interstellar comets we found, and saying these are probably space probes. And there is no evidence, no strong evidence to back that up. The much more likely scenario is that it is a comet. It looks like a comet. It's outgassing in a weird way, but it's a comet. It's made of cometary things in weird ratios.
Cometary. There's another new word. Ices and cometary. This is the ices commentary.
I don't know. I find that the strong push from that one voice to say for sure this has to be an interstellar spacecraft is just an odd. I don't know why that person is so keen to try and prove it when every argument they use is easily debunkable.
It's a fun thing. It gets people interested in astronomy. I don't mind when people discuss, could it be alien? But yes, there's no good reason to believe it. Just like I don't have definitive proof that the tooth fairy isn't real. I mean, when I was a kid, money appeared under my pillow. But I'm just saying I have no good reason to believe it's true. So we're not ruling it out.
Millions of children around the world every day collect data indicating that the tooth fairy exists. You're right, yes.
But I still don't feel we have a good enough reason to believe she is real. Of course she is real, we know that. But I just saying, okay, it might be 0.0000001% chance it's an alien visitor, but there's no good reason to believe it. But it is really cool, and it is really cool that we have the telescopes and the technology to start discovering these interstellar, visitors, if you will, not sentient visitors, but this is something that we never really clocked until now.
And I think that you make a really good point, because it's great to discuss it. And I was just reading a paper the other day about a group that's saying, well, what if there were spaceships from other civilizations that were dead spaceships that are just floating through space? We have the Voyager spacecrafts, right? They're flying off from the sun right now. And if there are spacecrafts out there in the universe from other places, would we see them in our solar system as interstellar visitors? And what would we look for? And what they're doing is they're going to old sky surveys, photographic sky surveys from the 40s and the 50s, and seeing if they can find things moving through the sky before we launched things into space, and seeing if they match what you would expect a spacecraft to look like. And so far they found nothing, but the questions are worth asking, right? Very, very much they're worth asking. But when, in this case, I think that it's pretty easy to say, yeah, that's probably a comet.
Yeah, but it is cool that its tail's going the wrong way, that it's made up of stuff, that it's off-gassing, if you will. And it's an exciting thing. Will we get it? What will be the best look we get of it around October 27th or 28th, when it's the closest it'll be to us?
Yeah, it's going to make its closest approach, and then off it goes. So, there's an arsenal of observatories and spacecrafts, both on the ground and in space, waiting for the best. It's on the other side of the sun right now. So we can't observe it, but it's coming out eventually, and we'll get a much more data on it, and hopefully be able to convince Avi Loeb that it's probably not a spacecraft. But that's the beauty about this story, is that we only saw the first half. Is like we're getting the second half of the story after it comes out the other side of the sun, and we're going to be able to ask more questions, get more data, and I think there's much more still to be learned about this comet.
I agree with that. The photos won't be dramatic. They won't be like HD 4K, but they will be a little better than what we have now. The object is called 3I Atlas. We'll be back with Dr. Jesse Rogerson as we discuss putting a nuclear reactor on the moon. Stay with us.
When did making plans get this complicated? It's time to streamline with WhatsApp, the secure messaging app that brings the whole group together. Use polls to settle dinner plans. Send event invites and pin messages so no one forgets Mom's 60th. And never miss a meme or milestone. All protected with end-to-end encryption. It's time for WhatsApp. Message privately with everyone. Learn more at whatsapp.com.
Broadcasting intimate details and useless information from an undisclosed location in New York City. The Last Show with David Cooper.
Nuke the moon, because you gotta nuke something. That's a subtle Simpsons reference. It's Science Talk here with Dr. Jesse Rogerson, who's a professor at York University. Check out his book, Daydreaming in the Solar System. And we are looking at maybe putting nuclear reactors, or some people would say nuclear reactors, on the moon to help us with all our lunar power needs, of which currently we have none. But in the future, we may have a lot. Jesse, welcome in.
Hey, man, let's talk about nuclear power on the moon.
Why not? You got to talk about nuclear power. It was nuke the whales on The Simpsons. And they're like, why would you want to nuke the whales? And I believe it was Nelson who said, you have to nuke something. It's a really stupid throwaway comment. But yeah, we're going to be on the moon, mining, studying. There will be bases there. There will be a presence there. We are going back to the moon. We've got energy needs, and I don't think burning coal is going to cut it.
Yeah, I mean, you have to be novel here, right? A permanent presence on the moon is very different than what we did in the 60s and the 70s, which was dropping down for a day, 2, or maybe 3 days, depending on the mission. And there you can do it with your power needs are wrapped up in like batteries or solar power. It's quick and in some respects easy. But we are not interested in that anymore. Humanity in general wants to get further and further and further out into space, and this new interest in the moon is really a stepping stone. Like, obviously, there's lots to learn about the moon. We need to learn more about its origin, what it's made of, what the water is like there. There's lots of interesting geological questions about the moon, but we are using this, and it's long-term planning. We want to go to Mars, and we want to go farther. So we need to address things like how you grow food, how you deal with psychological effects of deep space exploration on humanity, and how do you develop power? And it's honestly, like, speaking as a Canadian, Canada is all about nuclear power, right? That's like one of the best ways. In Southern Ontario, it's our number one power source is nuclear power.
And Canada has exported plans to the CANDU nuclear reactor to all kinds of countries. In fact, I recently asked the Atomic Canadian Energy Authority or whatever for plans, and they said to me, no can do. Just see what I did there? Can do. I'm just saying Canada is a well-known nuclear kind of powerhouse of a country that has great technology when it comes to nuclear power reactors.
I literally have family members who've worked on those exact projects where they take those plans and go to other countries and help build. Like it's in my family. So that CANDU reactor that we've come up with, this design is much safer. It's very efficient. It's less prone to all the dangerous things that you're worried about with nuclear power. And so Canada, the Canadian Space Agency, has put out for contracts on this. Okay, we're going back to the moon. We're sending a Canadian astronaut to the moon, Jeremy Hansen, in like a few months on board Artemis 2. And now we need to think about how can Canada contribute to the power needs of this ongoing base on the moon. And so they've got some contracts out. One to sort of develop this low enriched uranium sort of micro reactor, a small one that you could bring to the moon. But then also to another company, MDA here, a very big space company, to make it more autonomous and be able to run on its own, so that you wouldn't need a lot of human intervention.
I mean, we're also hearing about micro nuclear reactors for like tech companies to power ChatGPT's data centers and Google's data centers. I feel like in the next 15 years, we're going to see micro reactors not owned by provinces and states and countries and, official power organizations, but just companies are going to have them.
I've actually heard that too. I mean, like what's the best way to create power that's the cleanest and the safest? Nuclear seems to be the only way. I mean, you have one big glaring issue with it, and that is, what do you do with the waste? And that's definitely an important question to sort of wrap your head around. But it's not, thinking about all the other ways that we develop energy, this seems to be the cleanest and the most straightforward. So, tech companies doing it. Another great application for this is places that are very remote. Canada is got tons of remote communities, and maybe they might be interested in these micro reactors that would get them off of things like burning coal or diesels. There's communities in Canada that run almost 100% on diesel, which is just, nobody wants that, right?
Well, it's precisely Canada with its can-do attitude and its can-do technology. I'm going to keep on making these jokes. Ever try to ask one of your cousins or family members who works for these nuclear companies for money, for a loan, and they say no can-do? Okay, I'll stop. But I'm saying, what will these reactors be used for? Like mining, bases, all of the above?
Yeah, I mean, there's a variety of things we want to do at the moon. All of the major operations at the moon that's going to come in the next 10, 20 years is going to be at the south pole of the moon primarily, because that's where we found frozen water at the bottom of these craters at the South Pole. There's water that's sitting there in ice form. We want to go there. We want to mine it. We want to see if we can use that water for humans, for doing growing plants inside of some sort of dome. Can we use it for fuel? Can we use it for breathing? Take the H2O and split it up. So you need power to run these facilities. That's what it would be for. A research outpost at the South Pole of the moon.
Let's go to our last story here. We found some rocks that are remnants of the way Earth was many billions of years ago, when things were very different. It was hotter, it was volcanically and tectonically active. There was all kinds of junk flying around in our solar system hitting us. Earth 4.5 billion years ago, you wouldn't want to hang out there, and you certainly wouldn't recognize it. But there's not a lot left over from it, like in a pristine way. A lot of it's been changed through erosion and life and geologic processes. How do scientists know that when they discover a rock, that it's old like that?
That's a great question. And I think what I love about this story is how a scientist or a group of scientists can take something that doesn't seem like it's that important and use it as a test to indicate something one way or the other. So I'll get to that in a second. It's all about potassium. But the story of our solar system is, we start as a big gas cloud. Gravity pulls everything towards the center. You form a star in the center. Most of the mass goes to the middle. It lights up and doing fusion, its own thing. And then a disk collapses around it, spinning around it. And inside the disk, you make planets and moons and asteroids and comets and stuff. And so everything in our solar system came from an original cloud of gas and dust that all had the same chemical makeup.
And do they call that a nursery, Jesse? And if so, it sounds like a chaotic and dangerous environment. Why does it sound like a nice place for children?
Certainly not the nicest place for human children, but the baby planets that we need to grow. This is the perfect place for those to grow and enrich. So this is the basic story. We've known about this for hundreds of years, this way that planets would form. But then there's this story of, how do you get our moon out of it? Because our moon is gigantic, absolutely massive in comparison to Earth. It's almost like it's a double planet system. And the way we think that this occurred is that when Earth was this early protoplanet, that there was probably a massive collision between it and some other protoplanet, that the debris of which created the Earth and the moon. Now that happened really early on, about 100 million years after the formation of everything. So it's so early on that any rocks that were there were probably completely scrambled by all the processes you're talking about. Not just the collision itself, but the literally billions of years of geological activity. So if there were rocks that existed, that still exist, from before that collision happened, the giant impact that created the moon, how would you find it? And it turns out you get into the way into the weeds of what isotopes of potassium exist in the rocks.
We got about 20 seconds. Why is this potassium so exciting to find? It just proves that this rock is old because it wouldn't exist in any other way if it was a newer rock?
So what they were able to show is that meteorites, or rocks that aren't on Earth, have a different makeup of the isotopes, 39, 40, and 41. And they found rocks that do exist on Earth have another kind. And then they found that if they simulate what the rocks would be like in the early times before the impact, that would have its own difference of ratio. And then they went to a couple of places around the Earth, found the ratios, and were able to see that those rocks probably formed before the giant impact.
Rocks from the early Earth. You heard it here first, Dr. Jesse Rogerson. Thank you for being here, Jesse. I appreciate you coming on the show.
Anytime. Thanks for having me.
Doug.
Limu and I always tell you to customize your car insurance and save hundreds with Liberty Mutual. But now, we want you to feel it. Cue the emu music, Limu.
Save yourself money today. Increase your wealth. Customize and save, we say.
That may have been too much feeling.
Only pay for what you need at libertymutual.com.
Liberty, 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 liberty.
Savings vary. Underwritten by Liberty Mutual Insurance Company and affiliates. Excludes Massachusetts.